Hello everyone, myself Akash, founder and director of Prime Minister of Mathematics, Amravati. In today's video, we will solve a question on real analysis from IIT JAM 2015 exam. Question is, let f from R to R be a differentiable function with f of 0 equals to 0. Okay. If for all x belongs to R, value of f dash of x lies between 1 and 2 where 1 is included, then which one of the following statements is true on open interval 0, infinity? Options are f is unbounded, option B is f is increasing and bounded, option C is f has at least one 0, and option D is f is periodic. So let's begin the solution. We will use the given information. So let's define the function f from R to R by f of x equals to 3 by 2x for every x belongs to R. We can see that by definition of f of x is polynomial function, and we know that the polynomial functions are differentiable functions. So f from R to R is a differentiable function. This condition is satisfied. Further, at x equals to 0, f of x takes value 0, that is f of 0 equals to 0. So this condition is also satisfied. Further, when we differentiate f of x with respect to x, then we get f dash of x equals to 3 by 2. And we satisfy this condition because 1 less or equals to 3 by 2 less than 2. So when we define f of x equals to 3 by 2x for every x belongs to R, then this function satisfies all these conditions. Okay. Now let's verify the options one by one. Before that, let's draw the graph of f of x first. Okay. At x equals to 0, it takes value 0. At x equals to 1, it takes value 3 by 2, something here. At x equals to 2, it takes value 3, something here. So the graph of function f of x will be look like this. Okay. That is f of x equals to 3 by 2x. Here there is a hole because I have drawn the graph of f of x for open interval 0, infinity. I have drawn the graph of f of x for open interval 0, infinity. Okay. Now, is f is increasing and bounded on open interval 0, infinity? Yes, we can see that f is increasing function on open interval 0, infinity, but it is not a bounded function. It goes to infinity. So f is not a bounded function on open interval 0, infinity. So option B is discarded because option B states that f is bounded on open interval 0, infinity. Now, option C states that f has at least one 0 in open interval 0, infinity. We can see that the graph of f of x never intersects the x-axis in open interval 0, infinity. So it has no 0 or root in open interval 0, infinity. Because we know that if the graph of function intersects the x-axis, then f of x has a root at that point. But here, the graph of f of x never intersects the x-axis in this interval. So f of x has no root in this interval. So option C is also discarded. Is f is periodic function? We know that by definition of periodic function, periodic functions are the function which repeats its value in regular period or interval. But we can see that in this interval, f of x never repeats its value. So f is not a periodic function. So option D is also discarded. So we left with option A, and which is the answer. Now let's prove the option A. Okay. What is given 1 less or equals to f dash of x. Okay. So integrating on both sides from 0 to x, we get integration from 0 to x 1 dx less or equals to integration from 0 to x f dash of x dx. Where we have used the properties of definite integral, we state that if f less or equals to g on some interval, say close interval ab, then definite integration from a to b f of x dx less or equals to definite integration from a to b g of x dx. Okay, we have used this property here. Now integrating, we get x less or equals to, here what will be the integration? F of x, where limit from 0 to x. So f of x minus f of 0. Okay. Now, given that f of 0 is equals to 0, so this will become x less or equals to f of x. Okay. So for the unbounded function g of x equals to x, we have g of x equals to x less or equals to f of x. As this function is unbounded, so this function is unbounded. So f of x is unbounded function. Option A is true. So answer to this question is option A. So if you found this video interesting and useful, then please like and share this video and subscribe to our YouTube channel. Thank you for watching.